Good afternoon. Today we will be briefly looking at the advantages of both solar desalination and recycled water in the continuing efforts to provide people with clean water. Recycled water, also known as reclaimed water, is defined by the EPA as reusing treated wastewater for beneficial purposes, such as agricultural and landscape irrigation, industrial processes, toilet flushing, and replenishing a groundwater basin. Note that the EPA does not specifically list drinking water in this list, which we will touch on in a moment. Basically, there are three stages. The primary stage, in which the large solids are removed from raw sewage as it passes through the bar screens. The water is then slowed down so sediments can settle to the bottom. In the second stage, where water flows into aeration basins where oxygen is mixed with the water and microorganisms which consume the organic material, and repeated until all remaining solids are digested by microorganisms. Finally, in the tertiary/advanced stage, the water flows through sand filters and is treated with chlorine, which is then removed by sulfur dioxide later. This process, on average, costs about $1,100 an acre-foot to produce, which is about half the cost of desalinating ocean water. It is used in many places around the world, such as in Israel, where it recycles about 90% of their wastewater. But there is a stigma in the US against it, which comes from the image of drinking water being toilet to tap. Because of this general disgust, less than 1% of total water in the US is recycled, which could be used to help areas suffering from heavy drought. If we can implement education programs around the US, it could be a relatively inexpensive, reliable, and safe water source. Another option to be looked at is solar desalination, which is desalinating salt water through the use of solar energy. There are two methods, direct and indirect. In the direct method, a solar collector is coupled with a distilling mechanism, and the process is carried out in one simple cycle. But this cannot produce much water per day, averaging about 2 to 3 liters, so it is more suited for small-scale needs, like families in remote areas. Indirect solar desalination is more for commercial use. It combines solar energy collection through photovoltaic panels with a proven desalination method, the most popular being reverse osmosis. The benefits include tapping into the huge source of salt water for people's drinking needs and less use of fossil fuels, but a con would be the extreme excess of salts, which can contaminate any environment where it is left in. Currently, it is quite expensive, but the number of plants has grown worldwide to more than 15,000. So if the technology can get there to make this more efficient, it could be the future of water. Overall, both of these solutions to our finite water sources are very creative and could be very beneficial. Currently, recycled water makes more sense with the process being proven and efficient, as long as we implement education programs to get the public on board. While the future may move to solar desalination once the technology is stronger and does not need to use as much energy. Thank you.